Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 93 that says restore IP address. So here we are given one IP address in the form of string and we need to restore it by putting some dots here. So let's see the question. This is the definition of valid IP address that says the four integers separated by single dots. Each integer is between 0 to 255 inclusive and cannot have leading 0. So these are valid IP address because there are four integers in them. Further, each integer is in the range 0 to 255 and no number has leading zeros. That means nothing like 0, 1, 1. So these two are valid IP address. And the other examples are like this, because here we have a leading 0 and here we have 312 that is out of the range, and here we have characters, special characters. So these are the definitions of invalid IP address. So here we are given a string as that contains only digits, and we need to return all possible valid IP address that can be formed by inserting dots into it. So we have to insert this dot between some of the numbers such that the output is a valid IP address. Okay, and we are not allowed to reorder or remove any digits. So we cannot remove any of the digits, or we cannot change the order of digits as well. And you may return valid IP address in any order. You can return the answer in any order. The order doesn't matter. So let us take a look at the first example. So here we are given this string. So the first possible way to put dot is between this 255 here, then second here, then here. So we've kept dots at these three places, and thus we divided this string into four integers. And yes, all the integers are in the range 0 to 255, and there is no leading zeros between any of the integers. So this is a valid IP address. Similarly, this is also a valid IP address. That's why these two both are our answer. No other possible valid IP address can be formed here. Further, if you take a look at this example, then only possible valid IP address is this, because there are only four characters. So we can just insert the dot between them. For here, 101023, these are the all five different valid IP address, starting from here, then this one, then this, and this. So basically, to insert a dot, we need to take some decision, right? Let me show you. If this type of string you have given, let's say this is a string 1 2 3 4 5, this is a string, and to make it a IP address, what you can do, you can insert, like you do like 1 dot 2 dot 3 dot 4 5, or what you can do 1 2 dot 3 dot 4 dot 5, or what you can do 1 dot 2 3 dot 4 dot 5. So these are all the possible valid IP address that can be formed from the given string. So what we are doing, we are just basically making or inserting a dots between them. So what we are doing here, we are making choices or decision. So we are making a choice, right? So whenever we are making a choice, this intuition will help us to derive approach that we can backtrack or recurse. So whenever we made any bad choice, then what we would do, backtrack. Good choice, then we will form answer. So this is how we will approach this question, since we are basically making a choice of where to insert and dots. Now the next thing to note here is we only need four segments, right? 4 segments. Like this is the first segment, this is the second segment, this is the third, and this is the fourth segment. We only need 4 segments, and each segment, what we need to check, that all the numbers in the segment are in the range 0 to 255 and no leading zeros. Okay, and if there are 3 segments or 5 segments, then it is not a valid answer and we won't store it. So we won't store it in our answer variable. Got it? So we need to form 4 segments, and each segment we have to satisfy these 2 conditions. And further, let's say we have segment this 1 2 3 and it is empty here. So now the next character is 4 that we have to insert. So to insert 4, we have 2 choices, that either to insert 4 in this last segment, or to insert 4 in by forming a new segment. So what are the two possible choices here is 1 2 3 4 and 1 2 3 and 4. So these are the two possible choices that we are making, either to insert the element in the last segment or to insert in the new segment. Say if you insert in the last segment, and also it is valid because it is less than equal to 255, and if you make a new segment, and also it is valid because total segments here are less than 4. So total segment is less than 4, that's why we can make a new segment here, correct? So these two are valid choices that we can make if we have this is the current state, and if we want to insert a new element. Got it? So based on all these conditions, what we will do, we will make a choice graph or a decision tree. And now let me show you here. So what we have string 1 2 3 4 5. Yes. So talking about the character 1, what you have the choice. Do you have to, can you insert in the last segment? No, there is and the current segment is empty. Initially we have the segment as empty. So what we will do, we will make means one new segment inside this vector of segments. So what we do, we made segment 1. Got it? Now for character 2, we have two choices here. The insert in original or make new segment. So if you insert in original, you have like this 1 2, and if you insert a new, make a new segment, you have like 1 2. Got it? Now talking about 3. For 3, you again have two choices, original, new. So if you insert here, then it would become 1 2 3, and here it would become 1 2 3, and here also same two choices, in original or new. So if you insert this into original, then it would become 2 2 3, and here it would be 1 2 3. Now talking about 4. So for the 4 also you have two choices, 1 2 3 4 and 1 2 3 4. Same as here, 1 2 3 4, 1 2 3 4. Same as here, 1 2 3 4. Sorry, here the original, and here 1 2 3 4, and here also same 1 2 3 4 and 1 2 3 and 4. See guys, one thing we missed here, that 1 2 3 4 we can't form, so we would break here, we would return, because this is greater than 255, and that is not valid. All other segments are less than equal to what? Less than equal to 255. So we would return here, so this one form. Okay, now talking about this last element 5. So here we would return, so no possible answer can be formed here. So let us take a 5, look at 5 here. One would be 1 2 3 4 5, inserting it in the original. Now making a new segment from here, 4 5. Here also two possible answer, 1 2 1 2 3 4 5 and 1 2 3 4, and we make a new segment 5. So similarly here also two different answer possible, like 1 2 3 4 5, 1 2 3 4 5. Same as here, it would be 1 2 3 4 5, 1 2 3 4 5. Same as here, 1 2 3 4 5 and 1 2 3 4 5. Okay, we make one mistake here. The thing was that 2 3 and 4 were connected, so it would be 1 2 3 4 5, and this would be wrong because 2 3 4 5 is greater than 255. Okay, and here it would be 2 3 4 5. So this is okay, 2 3 4 5. This is not okay, but this is okay. Okay, now moving ahead to this. it would be 1 2 3 4 5, and another possible answer from here is 1 2 3 4 comma 5, and here it would be 1 2 3 comma 4 5, and yeah, 1 2 3, see 1 2 3 4, and making new segment 5. But this is also not possible because the size is greater than 4, so we would exclude this. So this is the complete decision tree we made by adding each element to either the original segment or the new segment, and whenever any of the condition like this or this is violated, we would stop. We would stop and won't make any further answer. And also if we have total number of segments greater than 4, then also we would stop. So this was the complete decision tree, and from the decision tree what we would do, we would select all the segment that would be of size 4. We would select this, then this, then this, and this. So all those segments which are of size 4 we would select, and we would return as our answer, because the inner segment are valid, because we would check if the inner segment is valid or not already, and before adding the answer we would check if the segment size is greater than, that means if it is equal to 4 or not. If it is anywhere less than 4 or greater than 4, we won't add it to our answer. Like this, this is a size of 3, we won't add it. This is a size of 5, we won't add this. We will only add the segment size of 4 to our answer. So I hope you guys understood the intuition behind this question, and as well as the approach of how we would be solving this question. So since we have discussed this decision tree, what we would do, we would recurse and backtrack. So where backtracking is possible, anywhere where we are making a choices, original and new. So we have two if condition here to satisfy, and also we need one function to check whether if we include one element here, let's say 1 2 3, and if you include 4, then is 1 2 3 4 a valid segment. So we will write one function, valid is a valid segment, to check if a segment is valid or not. So I hope you guys understood the complete approach here. Now let's move on to the coding part, and we will code this complete thing. Okay, let me first start with making one answer variable. Let me initialize it globally. Now for each segment we would check is valid by passing a string of s. So we have to do this, and another thing is we have to call this function backtrack. What we would do, we would pass the given string and the index I, and further vector of segments that are vector of string, and a j pointer to point inside the segment. So these two things we have to code, and from here what we would do, we would simply make one vector of string that is temp, and we would call this backtrack function as 0 temp and j, and in the end we would simply return this answer variable. Okay, now what would be our base condition? So our base condition is when I reaches to the end of string, when I equals to s dot size, that is the end of string, then we would do something. Okay, and in the L, and we would do something and simply return. Got it? And now here we would have two type of string, original segment and new segment. So these are the two strings where we have to process the segment and based on the conditions, and we would do. So now before that, let's first code this is valid function. So based on this condition that it must all the numbers must lie between 0 to 255, and there must not be any leading zeros. So we will code here. So first thing, if s of 0 equals to 0, that means there is a leading 0, and s dot size is greater than 1. Means see, if you have only 1 0, then the first or the leading 0 is true, but if you have any number like this after the first 0, then it is not a valid condition. So here we would return false. Also there is one situation where if s dot size equals to 0 means there is no elements in the segment, then also it is not a valid segment. Okay, you need to have some elements ranging between 0 to 255. Got it? So now let me code for this condition that if s of 0 equals to 0 and s dot size equals to 1. If this is the situation, we would simply return true. This is the condition for this. And now let me initialize one number variable. And what we would do, we would convert this string as to the number. Let's say if it is a string of 255, then we would convert into the number 255. And we need to do this with the help of loop. We can't use stoi, because you can have some special character like this at the rate in some of the test cases where we would fail, our code would fail. So to handle this, what we would do, we would run a for loop for integer I equal to 0 up till size of s. We would take one n equals to s of I minus 0 character 0. So this will convert a character number to integer using by processing its ASCII value. If n is greater than equal to 0 and then n is less than equal to 9, that means it is part of the digit and not any ASCII and not in any special character like this. So if it is in the range, then what we would do, we would simply add to our num, and before that what we would do, we would also multiply num by 10 so that we can form like this way. So because initially, let's say for 255 string, what we are doing is initially we are adding 2, then to add 5 we need to do 20 plus 5, and then to add again the last 5 we need to add 250 plus 5. Thus every time we are multiplying by 10. So this is the logic here. And if num is greater than equal to 0 and num is less than equal to 255, then we would return true, and the else condition we would return false. Also here, if the digit is not in the range, we would simply return false. That means we have any characters that is not between 0 to 9. So this was the isValid function where we have validated if the segment is valid or not. Now here, the original segment and the new segment. What is the original segment? That is the segment at jth position. This will denote the last segment, and the new segment is equal to s of I, because we are starting a new segment from the ith digit of this string s. Now if first we will check if it is possible to add the character in the original segment. If original segment plus s of I, and this is valid, is valid. So we call this function is valid and pass this string. If this is the case, what we can do is we can insert this because we can update the original segment. That is, the original segment is s of j equal to what we can simply add the ith character, and we would call this function backtrack by passing I plus 1 as I plus 1 segment and j. And also now we will write the backtracking step that we would again update s of j to this original segment. Got it? Okay, this is one thing. Now if original segment dot size is greater than 0, so that means that we have some element in the original segment, so that we can now form a new segment as well in this situation. So here what we can do is we would call this is valid function, and what we would pass new segment this. And if a new segment is also valid and segment dot size is less than 4, because if there are already 4 segments, then we can't form a new segment, right? So if the segment size is less than 4, and if it is a new segment and the new segment is a valid segment, and also that is the last segment has a size greater than 0, then what we can form a new segment. What we would do, segment dot pushback new segment, and we would again call this backtrack function as I plus 1 segment array and j plus 1. j plus 1 because we have added one new segment. So here we didn't delete that because we just updated the original segment. And now we would write the backtrack code, that is segment dot pop back. That means we are just removing the last added segment. Got it? And if none of this condition pass, then we would simply return. Okay, so I hope you guys understood till here. Now let us store this value of all the segments in our answer. Now if let first check if segment dot size equals to 4, then let us take one temporary string, and what we would do, we would traverse this segment, then 4 I plus plus temp plus equal to segment of k. Instead of I will take k variable here because we are already using I here. And if k not equal to 3, then what we would do, we would also add one dot for this IP. Got it? This dot we are adding, and in the end we would push this temporary variable into our answer. Okay, now I think everything looks good. So let us try to now run our solution. Okay, it would be temp, and here it would be 0 because there is no j initialized. Null pointer. Okay, so initially there is nothing in the temp, and so we would push back one empty string. So because here we are using original segment like the segment of j, but there is segment is empty here, it is null. So to handle that, we are just pushing one null string here, so that we get something as the original segment. It would be dot. Okay, all the test cases are passed. Now let us try to submit this. So yeah, our code got accepted, and it is see, the approach, building this approach and the intuition was more important here, and then coding this, it was easy part. So I hope you guys understood the approach as well as the code here, and if you have still any doubts, then do let me in the comment section. And now guys, talking about the time complexity, the time complexity here for this type of solution is m to the power n, because where m is the total number of characters in a segment, and n is the number of segment. M to the power n into n times. But here, as you can see here, m is it is fixed, like it can be 0, 1, 2 and 3 because we have the numbers between that and 0 to 255, and n equal to 4 because we only have 4 segments. So this turns down to time complexity of bigger of 1. So similarly, the space complexity is also bigger of 1, as the number of combination possible here are fixed, or we can say the maximum number of combination possible here are fixed. Because that is if we have a very long string of, let's say 20 letters, what I assume 20 letters, but what is the maximum length of string you can perform that is valid? That would be 3, 3, 3, 3. That means all 4 segments are of size 3. That would be 12. And beyond this, it won't be a valid segment. And if it is not a valid segment, what we are doing? We are simply returning, and we are not checking ahead. So that's why the time complexity is this, and it boils down to big of 1, and yeah, that's the time and space complexity. So I hope you guys understood the question as well as the solution, and that's all for this video. Make sure you like this video and subscribe to our channel. Thank you.